Hi everyone, welcome to my channel. So, we have many ways to compare our life quality to our parents, grandparents, great-grandparents, or just anyone. We might want to compare the GDP per capita growth over the years, or perhaps infant mortality rate. We might compare those indicators across decades, or perhaps by presidents. I'm not saying that those presidents have a huge impact on the fluctuation of these series, but we just need a name to label the period of time. And in machine learning, we call this clustering. That's what we're going to do in this video. We're going to do clustering for time series. More concretely, we're going to look at the Consumer Price Index, or CPI, in the US from 1913 to January 2024, and then segment it based on the presidents and try to cluster it. Okay, let's study together. So first things first, let's get the data. I've got the data from the US Bureau of Labor Statistics. Here's the website and here's the data. It's in two-dimensional matrix. The rows represent the years and the columns represent the month. I'm going to pivot this data set so that we have a one-dimensional array. And then I need to also convert the index so that we have a date-time index. We do that with pandas. Basically, that's it for the first dataset. We can set it aside for now and get our second dataset, which is the president dataset. This dataset covers the president names and starting terms and ending terms. The only pre-processing I want to do to this dataset is to round the starting term. So if the starting term is from the 16th of the month, so 16th to the end of a month, I'm going to round it to the next month. Okay, so here I already printed labels before. So before pre-processing, we have Lyndon B. Johnson. He officially became president on November the 22nd. Because this is more than the 16th of November, I will round it so that only for this analysis purpose, I'm going to round it so that his starting term would be, where is it? This December the 1st. Okay, so yeah, after we have both datasets ready, we can merge them, both the CPI datasets and the president datasets, so that, like this, clean data here. So after we merge, we do a little more pre-processing, like filling the NA and dropping some NA values. And this is the clean data that we have. Maybe I should, maximize this. Anyway, so the clean data has 3 columns now: the starting term, the CPI, and the name of the president. Next, we group this dataset by the name and calculate the derivative of the CPI. I'm going to elaborate my reasons in the video after next. But I'm going to give you a brief introduction or sort of sneak peek to that. To answer that question, why I calculate the derivative, I'll show you first the raw series, the graph of the raw CPI. So as you can see, this series has been segmented into 19 unequal parts because we have 19 presidents over the span of more than 100 years. And as you can see, the range of CPI is so huge. It starts from 9.8 to over 300. So I guess it'll be more interesting to see the shape of the CPI series instead of the raw values itself. Here is the derivative sequence plots, and we put this into the DTW, or dynamic time warping algorithm. And the output of that algorithm is a distance matrix. And we use that distance matrix to do agglomerative clustering. And here's the cluster results. So yeah. Actually, this video is like a teaser for the next two videos. Okay, so for the very next video, I'm going to talk about agglomerative clustering. And then after that, I'm going to go into detail over DDTW, derivative dynamic time warping. To make sure you don't miss any of these videos, please subscribe to my channel and click the bell notification button. I'll see you next time. Bye-bye.